For participation activity number 11, kind of need to explain some stuff here. It goes over vertical asymptotes and horizontal asymptotes, but there's also this thing called discontinuities where there's like holes in the function. Vertical asymptotes are the easy ones. It's like you're looking for where there's a imaginary vertical line that the graph doesn't cross over. That's what an asymptote is. Which reminds me, I have a magnet in my office that says, "Kiss my asymptote." It's just one of my favorites. Anyway, I took a screenshot here of what it talks about how to find vertical asymptotes. And step 1 says, factor the numerator and the denominator. Now, I already have this example over here that they did. It's already in factored form. It says, note any restrictions in the domain of the function. The domain has to do with the denominator. So what number here and what number here would cause a 0? This one, if x equaled a -1, -1 plus 1 would cause that to be a 0, and you'd have a 0 times whatever, which would be 0. And then this one, this x, if it equaled +3, then that would be left out of the domain as also. So if you were asked to write the domain, I would say it's -∞ up to -1, don't include it, unioned with -1 to 3, don't include it, union with 3 to infinity. Okay, that's a domain. But in terms of the graph, actually only one of those is a vertical asymptote because, another color here, when I have the numerator and the denominator factored out, this x plus 1 and this x plus 1 cancel out, which means there is not a vertical asymptote at x equals -1, but there is a hole in the graph. So it's kind of like it'll go up to the -1 and then just jump over it and keep going. So it's like you're do. Oh, can't be that. Jump over it. Do and keep going. Okay. So the only vertical asymptote that I really have is at x equals 3, and you can see their dashed line there. So when they talk about, let me scroll up here, removable discontinuities of rational functions. A removable discontinuity occurs in the graph of a rational function at x equals some number a. In this case, it was -1. If a is a 0 for a factor in the denominator that is common with a factor in the numerator, which we did. We had x plus 1 in the numerator and the denominator, which cancels them out. But since that x plus 1 is in the denominator, x can't equal -1. But because there's a common factor of it in the numerator also, it's not an asymptote. It's just a hole in the graph. All right? Hopefully that explains that. Now, when it comes to horizontal asymptotes, there's some rules. It says if the degree of the numerator is less than the degree of the denominator, there'll be a horizontal asymptote at y equals 0, which is your x-axis. So if I had a numerator that was an x and the denominator was like x squared plus 1, the degree of the numerator is a 1 and the degree of the denominator is a 2. So that's this one. If the degree of the numerator is less than the degree of the denominator, then the x-axis, y equals 0, that is your horizontal asymptote. On the next one, if the degree of the numerator is greater than the degree of the denominator, which in this case, let's flip it over, that one, the degree of the numerator is 2. The degree of the denominator is 1. Let's see, degree of numerator is greater than the degree of the denominator by 1. no horizontal asymptote or slant asymptote. Okay? So if it's x squared over x to the 1, or x cubed over x squared, or x to the 4th over x to the 3rd is greater than the degree of the denominator by 1, there's no horizontal asymptote. And then the last one says, if the degree of the numerator, if the degree is equal, if the degree of the numerator is equal to the degree of the denominator, horizontal asymptote is at the ratio of the leading coefficients. So if I had like a 3x plus 1 over a 5x minus 6, these are both first degrees. 3x to the first over 3x to the first, 5x to the first, or they could be squared. This could be 3x squared and that could be 5x squared. If they are equal in degree, then let's see, how about I go with yellow on this? It says the horizontal asymptote is the ratio of the leading coefficients. The 3 and the 5 are your leading coefficients. So your horizontal asymptote will be at y equals 3/5. So if I scroll back up to this one, my numerator, if I FOILed that out, you'd get x squared blah 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 over, if you FOIL the denominator, you'll also get x squared blah 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 blah. The degrees are the same, so it's the coefficients in front. This is a 1 and this is a 1, and 1 over 1 equals 1. And if you look at this right here, there's your horizontal asymptote. It's going right through it. So anyway, when I get to number 11, it says find the vertical and horizontal asymptotes. Okay, I look at my denominators and I see that right here, x, if x equals 2, you get a 0. And right here, if x equals -5, you get a 0. And neither one of those has a common factor in the numerator, so those are both asymptotes. Let's see, the fields below accept the list of numbers or formulas separated by semicolons. So I'd have to type in 2 and a semicolon and then a -5. Those are my vertical asymptotes. The horizontal asymptotes, if you were to take this and FOIL it out, I would get 6x squared. I'd have 2x on the outside, -3x on the inside. So -1x in the middle, and then last times last is a -1 over, and then if I took the denominator and FOILed it, I'd get x squared, and then 5x and -2 is +3x minus 10. And if you look at this, the degree of the numerator is the same as the degree of the denominator, and so the ratio of the coefficients right here, this one's a 6, the denominator is an invisible 1, and 6 over 1 is 6, so this would be 6. And if I go real quick, 2 colon -5 and 6. How'd I do? Yay! And that's that.